Hello dear student, in this particular video we are going to learn about moving coil galvanometer. So its working principle is when a current carrying coil is placed in a magnetic field and it is going to experience a torque, and that torque is current dependent, and that torque tries to or tend to rotate the coil and produce angular deflection. So basically when we pass electric current through a coil and place it in a magnetic field, then based on the value of the current which is flowing in the coil develops torque, and due to that torque the coil rotate or gets angular deflection in the magnetic field, and that amount of torque or angular deflection is given by NIBA. This we have done in previous video, that when we place a rectangular coil in magnetic field, they are able to develop torque NIBA. In addition to deflecting torque, this torque we call deflecting torque. In addition to this, there is a spring mounted in the same configuration, and that provides the restoring torque. So due to spring, is given by some constant k into alpha, where k is called torsion constant. K is called torsion constant of the spring. Under equilibrium condition or in equilibrium position, deflecting torque will be equal to restoring torque. This two torque will be equal to deflecting torque. So K alpha will be equal to NIBA. So from here we can say the deflection, angular deflection will be NIBA upon K, or we can write NBA upon K into I. Now next to this is, this deflection alpha is proportional to the current which is flowing through that particular rectangular coil. So we can say the deflection produced in the galvanometer is directly proportional to the current flowing through it. So write that point as note. The deflection produced in the galvanometer coil is proportional to the current flowing through it. Okay, so if the current will change, the deflection will also change, the amount of deflection will also change, and we define from this equation current can be written as K divided by NBA into alpha, and this particular K by NBA we call this as G, and this G is representing the galvanometer constant K upon, where G is equal to K upon NBA, and this is called galvanometer constant. Galvanometer constant. Now, figure of merit of galvanometer. There is a term called figure of merit. Figure of merit of galvanometer. So this is basically defined as this particular factor. This G is called galvanometer figure of merit. So how do we define it? It is defined as the current which produces a deflection of one scale division in the galvanometer and is given by I upon alpha. So we know I upon alpha is Z, and that is equal to, from this equation we can write I upon alpha is K by NBA. So this factor G we call figure of merit of the galvanometer. Figure of merit of galvanometer. This is very important result. So in the next video we'll discuss sensitivity. So in this video this much only.